Go. Good morning to all of you. Today is the fourth lecture on the topics of electronics related to formation, that is creation and annihilation of electrons and holes. First of all, I want to discuss, as per the Fermi-Dirac statistics, the equation of charge carriers in terms of carrier density equation is explained here, where N indicates the negatively charged particle, electron, and P indicates positively charged particle, hole. And these two equations is the extract of Fermi-Dirac statistics. Next point, the properties of semiconductor is the well-known facts, and these are given here. These are explained here as the semiconductor provides the devices on the basis of optical properties of semiconductor, and ultra-modern appliances like high-speed network connection of the computer is explained on the basis of current flows through the semiconductor where diode behaves as the varying resistor, rectifier behaves as the one directional current carrying device, and similarly transistor gives the modified signal of high amplitude or as per the requirement of electronic circuit. In the case of silicon, that is as intrinsic semiconductor, the band gap is narrow, that is of a small height, and in this way the number of majority carriers are less in comparison to the extrinsic semiconductor. So, as per previous lecture, hole is formed when external energy incident on the valence band, then electron will become excited and going in the conduction band, and at same time hole is created. This is the formation process of the hole in the valence band, and semiconductor behaves as the conductor where current in the conduction band due to electron and current in the valence band is due to hole. After that, creation, we want to discuss the recombination process of electron and hole in the semiconductor crystal or in the semiconductor devices. After the hole and pair generation, its visualization is clear in the slide 6. Where hole is shown in the valence band and electron is shown in the conduction band. Now, under effect of electrostatic forces, under effect of thermal motion, or during the course of thermal motion of charge carriers, there is a possibility that the electron and hole bond breaks, and in this way covalent bonds breaking shows generation of electron and hole, whereas the mechanism of equilibria, that is, when charge carriers becomes maximum, then it shows the covalent number of covalent bonds inside the semiconductor crystal will become less. And possibility of recombination will become high. That is, probability of recombination of electron and hole will become high. Due to force of attraction, due to thermal properties of the material, and which are shown as the radiative recombination and non-radiative recombination. That is, in this diagram, three types of recombination are explained. First, when the electron of conduction band recombined with valence band hole directly, and the probability of this phenomena will become high when the number of majority carriers in the conduction band and in the valence band are more. And it is clear this type of combination is radiative combination because when they combined, then photon is formed and it will come outside as the radiative, as the light in the form of radiative recombination process. But in the next two processes, that is Shockley red hole recombination and Auger recombination, this is a non-radiative, because in this case the combination of electron and hole is in different way. In the case of Shockley red hole recombination, in between the midpoint of conduction band and valence band, electron and hole combined with each other. And in this process, the recombination will be processed in the intermediate region of the band gap, where heat is produced, thermal energy is produced, but it is non-radiative recombination because phonon is produced, not photon is formed. So we discussed here the radiative combination is the mechanism of photoemission process in the semiconductor, and this property is used in the light emitting diode. So it is necessary to understand the process of recombination in the semiconductor, and if this recombination is radiative, then it will be useful for the light emitting diode. And similarly, radiative combination occurs, it means photon emitted that has the characteristic of energy and very weak interaction with the material, that is semiconductor, and photons emitted from it. So it is called radiative recombination. In the slide 14, we want to explain the formation is different and recombination, Auger recombination is different. So in the case of Auger recombination, electrons of the conduction band are recombined with the whole of valence band, and during the process of recombination, energy is released, and this energy is used by the other electron. So in this recombination, extra electrons are required which absorb the energy of recombination process. And finally, it is said that Auger recombination is non-radiative and it is also observed that the concentration of Auger recombination events increases with the increased input energy intensity in the conduction band. Finally, by this lecture, I want to explain the summary of lecture on electronics the semiconductor with the advancement of technology will become highly appreciated, and in today's scenario, most of appliances in the home available based on electronics, because first process is the study of band theory, then we understand formation of hole, then we understand the value of virtual cell in the p-n junction diode, then we understand the value of doping in the semiconductor, and finally number of electric appliances and number of electronic appliances are compared, then we obtain, which depends upon electronic appliances mainly. Thank you.